Happy day, students. Let's discuss from grade 10 electricity lesson. So from this, what is meant by electricity? Electricity is nothing but it's a branch of physics. It's a branch of physics which studies about charges. Studies about charges. That is nothing but electricity. So it's a branch of physics which deals about or which studies about the charges. It's nothing but simply electricity. There are two types of electricities. One is static electricity, and second one current electricity. So what is the static and current? Static is nothing but rest. So that means the charges, the study of charges which are at rest are called static electricity. The study of charges which are in motion is called current electricity. Okay, static electricity is also called as electrostatics. This lesson will be there in 12th. Okay. Right. This is electrostatics or static electricity. Now current electricity or electric current. Current electricity or electric current. Okay. Right. So this is about electricity here. So static electricity as well as current electricity. Two types of electricities. Now which lesson we are going to discuss? Which topic, either static electricity or current electricity? We are going to discuss fully about electric current. That means current electricity we are going to discuss. Okay. So in this current electricity, like we are going to discuss about what's meant by current electricity. It's the study of charges which are in motion. It's nothing but current electricity. Fine. So if this where these charges will be there, what is meant by charge? Simply here is also charges, study of charges at rest, study of charges are in motion. What is meant by these charges? Simply what is meant by charge? Charge is a property of matter. Simply, it is a characteristic property, it is not a fundamental property. Okay, it is a property of matter. Charge is a characteristic property of matter. Fine, right? So it can exhibit or it can produces electric as well as magnetic fields. It can produces electric field and magnetic fields. Simply, that's all about charge. Electric as well as magnetic fields. So simply, charge is a characteristic property of matter. It produces electric as well as magnetic fields. When electric field will produce, when magnetic field will produce. If the charges are in rest, it can produce only electric field. If the same charges are in motion, then it has electric field as well as a magnetic field. Okay, clear? Understood? Right. So this is about a charge. Here there are few properties are there for charge. Few properties are there for charge. So what are that? Properties. Properties of charge. What are that? Basically, first one can be taken as charges. Charges are two types, right? What are the charges? Like South Pole and North Pole, we have two charges here. One is positive charge and other one is negative charge. So here two positive charges, that means like charges repel each other, unlike charges attract each other. Okay, like charges means same charges, unlike charges means opposite charges, positive charge as well as negative charge. Okay, and then next, it has an additive property. It is an additive property. So what is meant by additive property? Additive means we are going to add it. Okay, so that means, for example, let's consider an isolated system. In this isolated system, there are positive charges as well as negative charges. Positive, negative, negative, positive, a positive. Okay, so let's check how many charges are there here. 1, 2, 3, 4, 5, 6, 7 charges are there. In this, how many are the positive charges? 1, 2, 3, 4. Negative charges are 1, 2, 3. What is the total charges acting here? Here plus and minus, this plus and minus, and this plus and minus gone. Remaining what is there? Only positive charge. Okay, so additive properties means we are going to add all the charges which are in isolated system. Isolated system means it is a nothing will comes inside and nothing will moves outside, as like our corona. So in the corona we are facing like isolated, right? If we got a corona, then what will be in isolated, right? So isolated means no one will comes in, no one will goes out. That will be isolation. So same thing will be here. These charges will be inside only, it will not goes anywhere. So these charges will, how many charges will be there? We can add either positive or negative. Total charge may be negative or total charge may be positive. Okay, now, right? Next. So next one it is a scalar quantity. Charge is a scalar quantity. Okay. Next. Next it is conservation of charge. Conservation. Conservation of charge. That means charge neither be created nor be destroyed in an isolated system. So here same we can consider same object. Okay, charge is there inside an isolated inside the system. This charge it will not going to come out and some other charge will not going to get in. Right? This is called conservation of charge. Simply the charge neither be created nor be destroyed is called conservation of charge. Okay, right. So next one, the most important point, it is a quantization. It is a quantization of charge. Quantization. So it is a quantization of charge. What is this quantization of charge? So quantization of charge is going to denote with the capital Q. Q equal to Ne plus or minus Ne. What is this plus or minus Ne? N is nothing but integral multiple. E is nothing but charge of an electron. Okay. Q equal to plus or minus Ne. So Q equal to N is nothing but integral multiple. E is nothing but charge of an electron. Simply quantization of energy is nothing, quantization of charge is nothing but it is a product of integral multiple of charge of an electron. Okay, so that what is the charge of an electron? So this will be the electron is going to denote with like this. So charge of electron is minus 1.6 into 10 power minus 19 coulombs. So what is meant by this coulomb? We did not hear till now anything anywhere. Coulomb is a unit of charge. Coulomb is the unit of charge. Okay, clear? Understood? Right. So next another point. Charge is invariant. Charge is invariant. Invariant means charge is invariant. What is meant by invariant? So for example, let's consider I have a charge here. When it is in motion, when it is moving with some speed, whether is it going to lose any mass? No, right? So that only we call this a charge is invariant. Whenever it is staying at rest, is it going to gain any charge, any mass? No. So that we call as charge is invariant. Okay. These are all the properties of charges. Still we have to know, we can mode. So these are the charges are enough as of our 10th for board. Okay. Clear? These are the properties of charges. Clear now? Right. Now we are going to discuss about, simply once again I want to discuss about charge. Charge is nothing but it's a property of matter. It can produces electric as well as magnetic fields. Okay. Right. Then will be quantization of charge. Q equal to plus or minus Ne. Mostly we are going to take Q equal to Ne only. Okay, where N is an integral multiple of charge of electron. Q equal to Ne, where n is the integral multiple, E is the charge of an electron. Charge of an electron is 1.6 into 10 to the power of minus 19 coulombs. Okay, clear? Understood? Next. So now here I want to discuss about electric current. I am going to discuss about electric current now. So till now what we have done? We learnt about the charges. Okay. We learnt about fully charges only. Okay. Now we are going to discuss about electric current. What is meant by this electric current? Electric current. So electric current. It is going to denoted with capital I, or it may be small I also, not an issue. So electric current is going to denoted with I. So what is meant by this electric current? It is defined as rate of flow of charges, simply rate of flow of charges. How the charges are moves, that is nothing but electric current. Rate of flow of charges, where these charges will move? Through a conductor. Okay, so let's consider a conductor. This is the conductor and this will be the area of cross section, and here is also it will be an area of cross section. So there will be electrons inside it. So now these electrons will move different directions when you did not connect any external source, any external energy. If you did not connect, now this will move in different directions. Okay, so these are electrons are nothing but charges. So when these charges are in motion, that we call as electric current. It's nothing but current electricity. Okay, so now rate of flow of charges through a conductor is nothing but electric current. So I equal to Q by T, where Q is nothing but what? Charge. T is nothing but time. I is nothing but electric current. So electric current is nothing but flow of charges through a conductor in unit time. Simply, you can write simply rate of flow of charges or the flow of charges through a conductor in a unit time is nothing but electric current. So it is a formula for electric current. It is a scalar quantity. It is a scalar quantity because it does not obeys vector laws of addition. Okay, na? Right. I equal to Q by T. It's a scalar quantity. Okay, right. So in the conductor, these charges are there, right? These charges, it's about to move in one direction. When if we connect some external source, this all will move in particular direction. So let's consider all these charges will move in this particular direction. That means you are going to connect one external source. That external source is nothing but a battery. Okay, so that current always moves from high potential to low potential. Positive terminal is high potential, negative terminal is low potential. Okay, so that means this is a positive, this is negative. So it is a high, it is a low potential. So now current always moves from high potential to low potential. Okay, so in a conductor, what are there? Electrons as well as protons, both will be there. Okay, so now here this is the direction of protons. Then what is the direction of electrons? It is opposite to the direction of protons. That means generally we learned that electric current is nothing but it's a flow of charges, right? Or simply we learned that it is the direction of electron, right? Actually the direction of current is along the direction of electron. Which direction? Current direction. Along the direction of electron. That means it will move from negative to positive. That means electrons are moving from low potential to high potential. Okay, we will discuss that potential little later. So electrons are moving from low potential to high potential. Then sir, the direction of current you are saying positive to negative. Yes, the direction of current is before they found direction of electric current, they mean direction of electron, they found that direction of current. So direction of current always moves from high potential to low potential. That means the direction of current conventionally, it's important, conventionally the direction of current is moving along the direction of protons. How the protons are moving? High potential to low potential. Okay, electrons are moving from high potential to, sorry, electrons are moving from low potential to high potential. Conventionally, the direction of current is taken along the direction of proton. That means high potential to low potential. Clear now? Understood? Right. So now, what is the formula for electric current? I equal to Q by T. So just before we discussed about Q quantization of charge. What is the formula for quantization of charge? Ne plus or minus Ne. Let's take Ne. Here Ne into time t. Okay, right? IE equal to Ne by t. It is also one of the formula. It's also one of the formula for electric current, as well as this also. I equal to Q by T. Okay, clear now? Right. So in this main, what we have discussed, electric current is nothing but it's a rate of flow of charges through a conductor, and it's a scalar quantity, and its formula is I equal to Q by T and I equal to Ne by T. Then can you tell me what is the units for electric current? What are the units for coulomb? Charge, coulombs by time. Time means second. So coulomb per second is nothing but ampere. 1 ampere equal to 1 coulomb per 1 second. Is it? Is it clear? 1 ampere equal to 1 coulomb per second. Is it correct or not? Right. So how can we define 1 ampere here? If 1 coulomb of charge flows through a conductor in a 1 second, that is nothing but 1 ampere. Okay, simple, right? 1 ampere is now defined as when 1 coulomb of charge flows through a conductor in 1 second. It's nothing but 1 ampere. Okay, clear? Understood? Right. So conventionally the direction of current is from positive to negative. Actually it will move from negative to positive. So the direction of current is along the direction of proton. Actually the direction of current is along the direction of electron. So that this consideration we call as conventional current. Okay, clear? Right. So shall we solve few problems on it? Yes, let's take. So an electron, okay, so an electron draws a current of 0.5 amperes, 0.5 amperes through a conductor, in 5 seconds. In 5 seconds, electron draws a current of 0.5 amperes through a conductor in 5 seconds. Calculate. What can we calculate? We can calculate the charge. So what is the formula here? So let's consider the question. Current they have given, I is 0.5 amperes through a conductor in 5 seconds. What is the charge? Okay, so I equal to Q by T. So we want to find q equal to I into t. So then q equal to, what is I is nothing but 0.5 into time is 5, right? So 0.5 into 5, how much will be 0.5 into 5? It will be 2.5. What are the units of charge? Coulomb. So 2.5 coulombs of charge will be there. Okay, right. Now I want to give one important question here, that is uh, calculate the number of electrons. Calculate the number of electrons which are present in 1 coulomb of charge. Okay, this is the question they asked. So in the question they asked us to find number of electrons n which are present in 1 coulomb of charge, q equal to 1 coulomb, and you know the charge of electron. What is the charge of electron? Minus 1.6. Let's take 1.6, no issues. 10 power minus 19 coulombs of charge. Okay, so q equal to Ne. There q, don't consider for here capital small q, capital Q, it's nothing, everything is same only. So q equal to Ne, q is 1 coulomb, so 1 equal to n into number of electrons. How many? We need to find. Charge of electron is 1.6 into 10 to the power of minus 19 coulombs. Okay, so n equal to 1 by 1.6 into 10 to the power of minus 19. So n equal to 1 by 1.6 into 10 to the power of plus 19. It's in denominator and I will take it up 10 power 19. So n equal to 1 by 1.6 means how much? 0.625 into 10 to the power of 19. How it will comes? Let's see. So if you rationalize with 10 into 10, rationalize with 10 by 10, then 10 by 16 into 10 to the power of 19, right? So still I want to simplify this like 100 by 16 into 10 to the power of 18 here. Here 19, no? So 1 I have taken here, it will be remain 10. So after calculating, how much will get? So it will be 6.25 into 10 power 18. 10 power 18, what it is? Electrons. Okay, so n equal to how much? 6.25 into 10 to the power of 18 electrons. Okay children, I think is it clear? Alright. So next, here they may ask you like I equal to q by t, right? Then I equal to q is nothing but Ne by t, and I want to give one more formula here regarding electric current, that is nothing but I equal to, let's take that q by, when an electron is moving, it is moving some speed, no? Speed equal to distance by time. If it is moving in a circular path, the distance is 2 pi r by t, is it? So from this, that t equal to 2 pi r by v, is it? So can I substitute that t here? 2 pi r into v, is it? I equal to qv into 2 pi r. Okay, for NTSC, this based on this kind of things you may have questions. Okay, clear? Okay, fine. So next we will discuss about potential difference. Okay children, is it clear? We shall discuss about potential difference.